Oh, Carson, same. I actually have it right here. We've been mainlining coffee this morning. And I'm so excited for the November IPFS Community Meetup. Has anyone else had breakfast? I'm sure it's probably closer to lunch or dinner time, where some of you all are joining us from. Ooh, peanut butter on toast. I haven't done that in a while. That sounds amazing. 6 p.m. That's, ooh, Chinese takeout for breakfast? Oh my gosh. I think that food talk is probably my favorite part of the meetup so far. Is it almost time? Are you all ready? Only one more meetup after this left in 2020. All right, I think we are ready to go. All right, so hello, I'm your host. I'm Jen Turner, or Jen Writes on Twitter and GitHub. And I've been with the IPFS project for a little over 2 years, working mostly on the IPFS newsletter. So if you read that, this is the voice inside of your head. And I've also been doing work on the blog over at blog.ipfs.io. Some of you might also recognize me from my work with Node.js or NPM, but for now, I'm firmly an IPFS fan. And thank you, Jessica, for dropping the link to the newsletter in the chat. If you haven't subscribed yet, I highly recommend it. I'm recommending it as a friend. Okay, so let's get started because we have a jam-packed schedule of speakers joining us today. And we just need to go over a couple of quick things. We're very excited that you're here, but being a part of the IPFS community means abiding by our code of conduct, which basically means treat everyone with respect. So we're building the future of the web, and that can get messy, but the way that we interact with each other should always be guided by kindness. A couple of other notes here. Yes, and Jessica has dropped the link to the code of conduct. So if you've never checked that out before, you should go and give it a read. Like I mentioned before, there's a Q&A button located at the bottom of your screen that you can ask questions of the speakers in, or questions about IPFS, and we'll figure out a way to follow up with you and get you an answer. We're also on YouTube, and I should say Meetup. So you can watch past presentations on YouTube and sign up to get notified of upcoming events if you join the Meetup, but we'll have more links on that for you later. So, and also if you are interested in speaking at future meetups, there's an email address that you can email us, and we will get back to you about featuring you in one of our upcoming events. So with those reminders out of the way, I want to introduce our very first speaker. So Eric Myhre is an IPLD engineer. Oh, I skipped the agenda. Eric is going to talk first, then Jessica, then Mauve, and then we'll close out with Anthony Budd. We might have some time for Q&A in between those talks. So I'm going to introduce Eric while he's getting ready. Eric is an IPLD engineer at Protocol Labs. His background is in cryptography and trustable design systems. Eric's also the creator of Repeater. I'm going to say this wrong. Is it Reformat or RefMT?
More libraries than you should name.
Okay, but I do want to say you also created Go Sup, which is just fun to say. Eric joins us now on a break from climbing trees and dinosaurs to talk about recent developments in the IPLD world in a presentation that he likes to call IPLD, ASTs, schemas, and code gen. Oh my. So please help me in welcoming Eric.
Okay, let me see if screen sharing works. Yay. Might have changed the title of the talk repeatedly. It's okay. So I'm here today to talk to folks about IPLD and what we've done with this historically, what we're doing with it now, and what we're going to do with it in the future, because we've made a ton of progress in IPLD. The first time you might have heard of IPLD could have been several years ago already. It's a project that comes out of IPFS. The shared prefix IP is not a coincidence. And we've really grown the project a lot from its earliest beginnings as this thing that came out of IPFS. So I'm going to talk a lot about that transition. Quick recap, IPLD stands for Interplanetary Linked Data, and it did grow out of IPFS. And our goal with this is, when we started building IPFS, we were building this thing to make files shareable in a decentralized, like spread around the world sort of way. And some of the lessons that we learned while we were doing that is, my UI is giving us black boxes all over. Can I make Zoom not show Zoom overlays? Is that better? Hopefully nothing important shows up in that part of the screen. Okay, sorry. The goal of IPLD is to make specs and libraries that make it easier to develop interoperable, decentralized applications. So taking lessons we learned in IPFS and trying to generalize them and make them available to more people to use to build their own cool stuff. So a million years ago, IPFS was just this thing that stores files and makes them globally available, which is really cool and really hard. But it was just for files. So the first step of generalizing this was IPLD started as being this thing called DAGPB, which is short for Directed Acyclic Graph based on protobufs, which was a way to describe large blobs of binary data and link together into tree structures, and so go from there and be able to address those tree structures in this globally content addressable way. But it's really only good at that point for addressing blobs of binary data. And maybe application developers might want to do more than that. So this is the big dawning moment for what IPLD is really going to let us do. IPLD is nowadays about structured data. So by this, I mean something that's like probably vaguely recognizable as pretty similar to JSON. A dynamic format which you can use to store any data you want in a structured, useful way that you can build applications around. So specifically, when I talk about structured data and this data model in IPLD, we're going to have concepts like list and map, very familiar, right? Concepts you probably want when building your application data structure. The data model knows what strings and integers are, booleans, all of these common things. Null is in there. And slightly more than JSON, we also have the ability to talk about binary byte sequences, big large blobs, and links, by which I mean the CID structure that you're probably familiar with from IPFS already. So with this general data model concept, IPLD is no longer just about file systems and opaque blobs. It's about structured data. This is something that we hope people can use to build their own application logic. And we hope that we can give people IPLD libraries which can traverse this structure and do stuff with it. You can think of this as kind of like an AST, an abstract syntax tree. But it's kind of without the S, because this is codec agnostic. There's no single syntax of serialized data that you need to worry about. The IPLD data model can actually be connected to DAGPB, like we talked about earlier, or plain old JSON, or other formats like CBOR. And really any codec that you can imagine can be plugged into this data model. We even have bridges to other content addressable systems like Bitcoin, Ethereum, and really awesomely Git. As long as it has a hash, we can link to it. And as long as we can define a transformation from that serial data into our data model, we can traverse it and do stuff with it. So what kind of stuff? Lots of stuff. The most common thing is just to have a library which can traverse these data structures programmatically. That's cool. We've also built higher level features on top of this. For example, something called selectors, which is a declarative model for making traversals happen. I'll get to that more later. Some features called advanced layout, schemas. These will all have more slides, but in general, what can you do with a data model? build applications that are based on structured data and want to be decentralized. So, first cool feature, and an example of a thing that we can build now that IPLD has the data model, is something that we call IPLD selectors. Selectors are a machinery for declaratively specifying a way you want to walk over another tree of data, and the selector is evaluated doing that walk and selecting any data that matches. These can be created themselves with declarative documents that are still just IPLD structures, so you can draft them in JSON and it's just fine. And these are something that are built for a limited power of expressiveness, which is useful because you can actually evaluate these selectors in a very low trust environment. One of the purposes of selectors is you can draft one of these up, send it to some other computer in a network, and ask them to evaluate the selection for you. They could then stream back data that matches, and you could evaluate the selector yourself as well. Since these are non-Turing complete and have limited power, you can do this in a relatively safe way, even when you don't necessarily trust the person sending you queries, which is kind of cool. We're using features like this to develop new data transports, like GraphSync. I'm already running out of time and I have 8 million more things to talk about, so I'm gonna go real fast. We have a concept called ADLs. This is short for Advanced Data Layouts. Long story short, sharding is now a feature of IPLD. You can implement your own plugins for how you want to shard data and make it appear as data model nodes, so like the same maps and lists. And this lets us have transparent pathing even over really large sharded data structures. This is something that IPFS web gateways have had for UnixOS v1. Now we've generalized it and made it into something that you can use in applications with your own special logic. Selectors work over this, it's kind of cool. We also, for when we want to supercharge our own development and skip over a bunch of manual data validation, we've implemented a schema system. IPLD now has a schema language. You can use the schema language to define types that have semantic behaviors, structs and sum types, unions, enums, things like this that you're probably familiar with from other type systems you've used as a programmer. And combined with this type specification, in the IPLD schema language, you can associate a representation clause with this type clause. This describes how this information should be transformed in and out of the data model, and thus how individual codecs should proceed to represent it. By making these things separately tunable, we believe you might have some really cool features in your future. Types also have a data model interface themselves, meaning you can still run selectors, traversals, and write other generic code against data that's processed with schemas. You can use these any place you would use any other schema language. The coolest thing about these, we feel, is that schemas are optional. They're this thing that builds upon the IPLD data model, but they're not strictly necessary. Now, what's cool about this is it means you can use the schema system for feature detection. If you have a document which in the data model, or say this is written in JSON for clarity, you have a list and it just contains the number 1 and the number 2. You can match this against a schema that has some named type that's a list of integers. Clearly this matches. You could also match it against a schema saying it's a struct with 2 fields and a representation of tuple mode. So in general, you can use this kind of feature to structurally match on data and add types without having to embed the schema in the document and without necessarily having to make the document unreadable without the schema. You can also use multiple schemas to attempt to match the same data and use this to construct feature detection. We're very hopeful that this will let people build decentralized applications in a flexible, evolvable way that may never have been possible before. We've also got a bunch of really cool new tooling which has come out to this recently. We have syntax highlighters, courtesy of one of my fine colleagues. We have code-gen systems, which are appearing in Golang. These are in early alpha, but if you want to try it, it's pretty cool. Come try it. We have schema auto-derivers. This is something that is actually so cool, I barely understand it. This is, again, coming from a fine colleague named Rod. Something that's cool with this optional schema system is you can take data that has no schema previously associated with it and still infer a structural type which describes it. So people have been able to build tools that do this automatically. This GIF animating over on the side is such a tool, taking a look at a large dump of data from the Filecoin network and automatically inferring schemas for it. This is kind of cool. I can't wait, honestly, to see what people do with this. We even, the list just goes on and on, have bridges to GraphQL. Why not? Another colleague has built this system, which is a mostly one-way bridge from IPLD schemas to GraphQL. IPLD schemas are somewhat more expressive than GraphQL, so there are some interesting details to mind with this, but it is letting us write IPLD schemas and use GraphQL visualization tools, as well as submit GraphQL queries against APIs, which then transform that data into IPLD queries and do the thing. This is just so cool. Long story short, come build applications with IPLD. Cool stuff is happening over here. And I'll leave you with a bunch of links if you want to know more. There are specs repos where I think probably most of our interesting development goes on. There's also docs websites here. The development team on IPLD hangs out in IRC. This is also a bridge to Matrix if you're a fan of that sort of thing. And if you want to bug me elsewhere on the interwebs, @WarpFork is usually my handle. Find somebody with that name, it's probably me. Maybe. It's the internet. I don't know. Good luck. Did I make it in time?
Yeah, I think you did great. There was a question for you during your presentation, but if you want to go ahead and follow up in chat, that would be great. And thank you so much for your time today, Eric. And if people want to find Eric afterwards to talk, make sure to take note of these links. Oh, they're gone. But I do think that we have a link to your slides so that if folks want to reach out and ask questions, they have a way to do that. So thank you. Yes. Woo! Moving on to our next presenter, Jessica Hergert joins us from the Quest Network to talk about, I'm going to say this wrong, Vibenarium. Jessica is a distinguished interdisciplinary artist and engineer and has been creating peer-to-peer applications since 2009. Her background is primarily in broadcasting, fintech, and education. Jessica is best known for her educational environments, games, animated films, and applications. And with that, I would like to bring Jessica to the metaphorical Zoom stage for her presentation. Are you there, Jessica?
Yep, I'm here.
Awesome. Do you want to screen share?
I'm on it. I'm having to do this from a very small screen, so please bear with me. I'm going to have to go between my slides and my notes.
Perfect.
All right. So good morning. My legal name is Jessica, but a lot of people call me Jake. Today I'm telling y'all about the Vibenarium and everything that we have built for it so far. The Vibenarium is a collaborative, decentralized social network. I'm a 2D, 3D animator and audio engineer, and I am amazed of all the open source ecosystems that have been made possible in a large part by version control systems. Every day I use the most awe-inspiring open source software, and some of the best software in the film industry in general is open source, and still productions? I'm not. They're among the most centralized projects owned by a room full of people. I want to change that. And with the Vibenarium, I want to offer everyone access to the tools, project planning, and processing capabilities that make for the foundation of every major game and film production studio. The platform can be used for any digital media creation related activity. I have a background in educational software as well, so I also want to make this a fun learning experience and a playground for people who are discovering the creation and distribution of digital media together. I'm a peer-to-peer activist, so I've decided that I want to make this happen open source and most of all, free. So what do we need to make this happen? Collaborators are going to want to talk and have video conferences, so we need a messenger. The projects are going to be open source, so we'll need moderation. For that, we picked IPFS PubSub. It's reliable for small teams, fast and secure. We invented an encryption and authentication scheme. The channel name is comprised of different public keys owned by the creator or owner of a channel.
Jessica,
Yeah.
Sorry, I hate to interrupt you, but we lost your video. Can you still?
Oh. Yeah.
It happens. There we go. Perfect. Thanks.
So, yeah, we picked IPFS Pubs Up. Let's go back there. It's reliable for small teams, fast and secure. We invented an encryption scheme and authentication scheme. The channel name is comprised of different public keys owned by the creator or owner of a channel. In simple terms, the owner keeps a participant list, and removing people from channels is as easy as that. The owner removes the participant, sends a message to the participants using the easy public key and the channel name. The participants have the ability to verify the signatures on the updated participant list. If the signature validates, the participants update their participant list. It's the same mechanism when joining a channel. We're using invite codes, and the channel owner verifies them. Now, it may be possible that someone launches a directed attack against a project. In this case, the owner has the ability to simply change the keys and change the channel name and move everyone. Eventually, I would like to have this owner become a virtual role that's represented by results of quorum queries. But there are still limitations. We're not syncing the history yet, and it's very obviously alpha software. So we needed something else. We were undecided about creating a forum architecture like Reddit or Discuss first, or what we were going to do. Most of our communication is on video chat, so we decided to go with a Twitter clan. It's a simple little module. You can post stuff, you can reply to posts, everything you know from Twitter. We're using the IPFS DAG API for this, and we're simply sharing encrypted credentials for the latest DAG node on someone's timeline. Every timeline on our system is a DAG of posts and action nodes, a lot of like the recent activities on GitHub. So using this, we were able to schedule calls, have asynchronous discussion, and leave offline messages. But what else do we need? So what we're building next is the foundation for our asset library, a decentralized package manager on IPFS. And we're building an Ethereum-based incentive structure similar to Gitcoin. Items in the library can be shared and sold on the network, and people can offer premium and custom variations of assets that they're hosting on IPFS. It's the core of the Quest network. Since there's a crazy amount of applications for the social networking part of it alone, Since there's a crazy amount of applications for the social networking part of it alone, we're currently building out a social networking framework for this, the Quest network. It's a generic social network on IPFS, on which people can use the chat, feeds, marketplace, and game and app store to exchange services and products of all kinds. We have chosen Angular and Electron as an example environment because we believe it offers the best accessibility for beginners and developers coming from other languages and frameworks. The Quest network is already being used in Python on PyQt5, and we aim to provide the underlying library in Go and wherever possible in Rust as well. Our example app can be built for every major operating system and run seamlessly in the browser directly from IPFS. I'm the lead maintainer of a render farm, so when we fork into the Vibenarium, unfortunately, I didn't skip through the slides fast enough. I'm the lead maintainer of a render farm, so when we fork into the Vibenarium, we also want to offer decentralized processing capabilities. This allows teams to use their processing power for rendering scenes and assets. Additional computing power can be bought on market and added to a project into Plex. I'm also working on an FFmpeg WebAssembly-based online video and audio sequencer, and eventually we'd love to offer as many useful tools as we can. So much about the internalities. Now, I would like to take a few minutes to talk about the founders and our greater vision. So who are we? We're an international team of artists, creators, and engineers, and we believe that games, movies, shows, and documentaries should all be open. I'd like to especially thank Joppe Molinar and Jennifer Sizer and Steiner Bedari for their contributions and their work for the Quest network. Yeah, that's it. Please consider supporting us. We're always looking for help. Buy us a coffee. And we love to build a nonprofit for this project. If you know anything about that and you can help, sure. We're happy to be helped. Thank you for your time.
Thank you so much, Jessica. That was fantastic. And I think, is there a link that we can drop into chat for people to get in touch with you all?
We have a website, qdesk.org. I can drop it in the chat right now.
Perfect. All right. And if anyone has questions for Jessica, she will be available in the chat to answer them while we move on to our next presentation. Okay, so next up, our next speaker is the mononymous Mauve, a software consultant with a focus on local first tech, the web, mesh networks, which I think are crazy amazing, and how it all works together. Mauve is also the founder of Mauve Software Inc. and creator of Web Run Plugin IPFS and JS IPFS Fetch, which she is joining us to speak about today. So please help me in welcoming Mauve to the Zoom stage. This is such a weird year.
I forgot to unmute. Thank you for the intro. I'm Mauve. Nice to meet everyone. And today I'm going to be talking about the IPFS Fetch. Specifically, I want to look at how I've combined some of the usual webby interfaces we're used to with some of these cool peer-to-peer interfaces we're used to in IPFS. So there's my intro stuff. That's for later. I wanted to talk about how the web is good. I really love the web. I think it really kind of changed me as a developer years ago when I started using web tech, migrating from crazy stuff like Java and C++, and it was just so much easier. I could just slap together a text file, put some HTML on a page, put a little JavaScript and jQuery stuff together just to make something work. And then suddenly everything worked cross-platform. I didn't have to worry about like sending people executables, worrying about what platform they're on, and making sure everything actually displayed properly. It just kind of makes things work. And I really like how it kind of lowers the barrier to entry to creating cool things. However, the web, as it is right now, is also tied with something that I think is not as cool, and that's servers. I think servers are bad. On one hand, they enabled us to build up these networks of sharing information, but on the other hand, as an individual, a server is a barrier to entry. It requires more expertise in order to get anything started. For instance, you either need to like have your own machine running locally or have some sort of virtual machine, and then you need to think about like what kind of web servers you're going to host and all of this stuff. Especially with servers and the web, everything is kind of hinging around these servers. If I made some sort of cool like blog and I want to share it with my friends, I have to go through a server. If that server goes offline, suddenly my friends can't access it. Or if, say, somebody doesn't have internet or can't afford a fancy internet connection, or say, Twitter goes down again, suddenly all of that data is gone. It's kind of a pain, and I feel like it's holding people back from the stuff that they can create. So one thing that's kind of been popping up lately is third-party services that offer hosting for a small fee. So instead of me having to like set up my own server and configure it and make sure everything is online, I can pay money or pay data to some third party, and then they'll kind of do everything for me, which is great. Except then the thing isn't really totally mine. If say it's a Google product, it'll probably, die within a few months or get deprecated later on. Or say if it's any other tech thing, it might just change under my feet or run out of business. And suddenly any sort of community I built, anything that I did with that is just gone because it's too hard for me to set up it'd be nice if none of this stuff was a problem. Like, I want the web without all of these servers and all of this extra crust. So with that in mind, I think peer-to-peer is kind of the thing that changes everything. So obviously this is an IPFS meetup, so I think most people are comfortable with peer-to-peer, but just to reiterate, with the server situation, everyone connects to this one central source. With peer-to-peer, people connect directly to each other. So if I want to make a blog, I can send a link to a friend, and then they can download that blog directly from me. And then if a third person wants to view my blog, then they can download it directly from me and my friends and anyone else that has a copy. And what's cool is I didn't need to set up a server, hopefully, to get this running. I just kind of put some files in a folder and then it just works, which I think is really great and enables a whole bunch of use cases, including stuff working over local mesh networks or offline first. Say I'm in an airplane and I want to mess with all of my data. Centralized server-based apps can do these use cases, but it's a lot harder. Whereas when you build on peer-to-peer first, it's suddenly way easier. So what is peer-to-peer and the web combined good? What would that even look like? For instance, right now, let's think about like how people actually interact with the web on a slightly lower level. So the web right now is made on HTTP, which is a protocol that servers speak. It uses URLs, so links to resources. It uses HTTP methods, which is like phrases that you're saying to the server. For instance, I want to get some data. I want to post some data to the server. I want to delete this data. Different kind of actions that you want the server to do for a given URL. And then normally how we interact with this is we load a web page, or we load a video, or we load some JavaScript in a web page that does something interesting. Developers these days use an interface called fetch. So if you have some sort of fancy React app, it's a pretty good chance that somewhere underneath that stack, there's a call to this fetch API in the browser. So with that in mind, I want to propose what a peer-to-peer web might look like. So what if the same way we could get data from HTTP, we could get data from IPFS or IPNS. For instance, I take an IPFS link with a hash, I shove it in my browser, or I shove it in my application, and then it can load the data. Similarly, I want it to resolve mutable data through IPNS automatically. And that's actually something we kind of have already via stuff like IPFS Companion and various gateways and integrations into apps. So kind of the new thing I want to introduce here is the idea of posting to IPFS. So right now, if you want to add stuff to IPFS, you need to use one of these APIs. You either need to talk to some sort of HTTP server again through an interface, or you need to use a pure JavaScript implementation, or you're using a Go library or Rust or whatever else. And they all have these like their own way of speaking to IPFS. With the web, what if we could take that exact same metaphor and shove it into IPFS? And then similarly, what if we could take a similar metaphor and put it into IPNS? For instance, with IPNS, just for those that haven't looked into it yet, it lets you take a IPFS URL. It lets you take a name of some sort of key that you own, and then it lets you publish those together and gives you a special IPNS URL, which is kind of like an IPFS URL that can change over time. So I think these tools are fairly accessible. And in fact, what I've done is I've integrated it into a web browser called Agrigor. So in fact, that's what I'm using to load this presentation right now. I'm not loading the presentation from IPFS, so I'm cheating a little bit, but I could. So my idea is, what if we can take all of these different peer-to-peer protocols, for instance, the Hypercore protocol, which I'm using to load my slides, IPFS and IPNS for storing data, maybe Ethereum in the mix for interacting with blockchains. What if we could take all of these different primitives and kind of simplify them for average web developers? Like, if I know how to post something to an HTTP server, it should be even easier for me to post something to IPFS or ENS or Ethereum in general. I think that one of the goals for me with this web browser is to, one, build JavaScript interfaces for these different fetch APIs so that applications can integrate them into their apps separately, but also to see what it would be like to have a web browser that mixes all of these things at the protocol level. So I'm going kind of fast, so hopefully I'll have time for the demo and it doesn't fail spectacularly. So here is my web browser. Here we have the Chrome DevTools. Just to prove that there's no tricks, if I could actually type. So let's explore what it means to get data from a web page. For instance, what if we fetch something from Google? So the fetch API takes a URL and then some options for the request. So here what we're going to do is use the boring old legacy web and do a fetch request to google.com and see if we can get, oh no, Google doesn't want that. Oh no, I should have used a different URL here. There. Let's request my blog because it's less secure. So we've made a request. We see this time it didn't fail, which is great. And what we can do is actually get the contents of my blog's homepage. So we've just got an HTML string with a bunch of junk, doesn't matter. So now that's cool. How do we translate that to IPFS? So right now, if I want to use IPFS, I need to import a bunch of libraries, even though they're really great and it's been a joy to work with them. But it's like a new thing to learn as a web developer. What if instead of importing JS IPFS or some native library, I can just fetch directly from IPNS? Say I want to get the IPFS homepage. So again, I do the request. It'll take a little bit longer to load because my cache isn't hot, if that makes sense. But subsequent requests are a lot faster. So that first delay there, it was fetching data from IPFS onto my browser. And then just now it was serving it from cache. And so it should be available offline. But again, just like we did with with my blog, we can look at what the text for the IPFS homepage is, and it's just some HTML. And so what's cool, any URL that uses IPNS or IPFS could just be shoved into this fetch interface, the exact same way that you would with HTTP. And it's the exact same thing that you would use with images or videos or whatever else. Instead of having to have a special plugin to load something from, say, a gateway, or loading in memory, or doing something crazy like what WebTorrent does, where it downloads chunks on the flies and builds up a video stream in JavaScript. Whoa, we can just paste a link in this exact same way that we're used to with regular web apps. So next I'm going to showcase the super difficult challenge of getting stuff onto IPFS, which is going to be really hard, many lines of code. All we got to do is, again, we do a fetch request. And this time we're going to say IPFS. And since we want to upload a file to IPFS, we don't actually have a domain name that we're uploading it to. We're just going to say IPFS : / and then add a new slash and say index.html. And then we're going to say that the HTTP method we're using is post. The default was get, because this time we want to upload some data. And we're going to say that the body is some HTML. So I think I had a bug earlier where it wasn't loading after uploading. So we'll see if it works. Fingers crossed. So obviously we need a good doc type, and we need standard modern elements. So, and boom, that's it. I just created an IPFS site. Whoa. And if I want to get the URL for my new sites, I look at the response from the IPFS protocol, and here I have a regular old IPFS URL. So this might be a little bit different from what you're used to in terms of URLs because it doesn't start with QM. That's because we have to use a different encoding for web pages because they're case insensitive, whereas the default IPFS multi-hash encoding is case sensitive. So now that we have this URL, what if we want to update our mutable IPNS URL? So similarly, we'll do another fetch request. And this time we're going to do a publish request on IPNS. So in IPFS fetch, you can just make up whatever you want for your IPNS name. This will generate a secret key under the hood for that name, and it'll generate an IPNS URL for you. So this is useful as an application developer because you don't have to manage keys yourself. You just make up a name, and then the protocol handler does it for you. So let's call it my blog, and then we'll say method publish, and the body will be our IPFS URL that we just created. So we're gonna do that, wait for a bit, and then we can see our new IPNS URL by looking at the response. Whoa, so that's the live demo. I'm not gonna push my luck to go further, but you can see that with this interface, the same stuff that web developers are used to using for getting data from HTTP, we can do with IPFS, and uploading and loading data is super simple, and it's using the exact same web metaphor that we have for all other files in web apps. So basically, I just wanted to kind of show this to everyone to show that there's easier ways we can think about protocols, and I think that a lot of protocols are actually very similar, and I think that the way they work can be very beneficial to the web. Some of the things I've been seeing a lot in the hypercore community is web apps that kind of modify themselves or create themselves by kind of writing to their own data. And I think it'd be really cool to see more stuff with IPFS that does similar things. Like say a blog publishing platform, which doesn't send anything to a server, which doesn't touch any extra file system. It's just a web app. So hopefully this was useful. Hopefully this will inspire people to make stuff. Thank you for the time.
Wow, that was so great, Mauve. Thank you so much. If you have any questions for Mauve, make sure to drop them in the chat. I think that the IPFS events chat admin has also been adding some ways to get in touch with Mauve if you have questions or you would like to work with their consulting firm. So let's go to our fourth and final speaker, Anthony C. Budd. Anthony is a Node.js and PHP expert. He is also the creator of IDEA, a platform of online services using alt tech infrastructure. He is going to join us now to talk about S4, which is an S3 compatible storage that you are able to access through Tor and distribute through IPFS. Woo! Thank you for being here today, Anthony. Are you ready to share your screen?
I'm ready to go. Cool. Can everyone see my screen? Good. So, hi everybody. My name's Anthony Budd. I'm developer of S4. A little bit about me. I've been doing web development really since I left high school. I've been doing PHP, Node.js a Laravel contributor. I've also done a fair bit of WordPress contributing throughout my career, but I tend not to talk about that too much. I'm an ex-Apple developer, and I've also developed a project called VIPFS, which you may or may not have heard of. It did quite well in the IPFS Reddit. And yes, I'm the developer of ID.io, which I'm kind of trying to create my own version of AWS using like purely alt tech. So that's kind of a bit of a challenge. And I run a delivery company called Teleport. I'll quickly touch on that right now because Teleport is really what funded S4. So basically, I run a delivery company in Austin, Texas, and we, as you can see, we've got a handful of quite large clients, and basically all the kind of income that I generate off this is mine, like 4 9-to-5s. It's my thing. That was what I do every single day. This is really what allows me to kind of make projects like S4 and VIPFS. So a little plug there. So great. So what is S4? S4 is designed to be 100% compatible S3 storage, accessed through Tor, and distributed using IPFS. It's 100% compatible with S3 and all their existing SDKs and whatnot. It's decentralized, anonymous, and it's obviously permanent because it uses IPFS. So I'll touch on the architecture quickly. So the way I've designed S4, I had a few kind of design specifications. I wanted it to not require any third parties or intermediaries, meaning that using typical HTTP domains is off the table, because that would require us having to register a domain with a third party. So Tor is heavily used throughout. Data is ingressed into an S4 server over Tor, and that can be done through Tor browser just by a standard user, or your code can write data to the to the S4 server. Then when you write data into the server, you can create buckets just like in S3. Each of your buckets get paired off with a key in IPFS. And every time you update the data in the buckets, the bucket will get published using that key. What this means is that you can address any of the content stored on your S4 server using this kind of URL here, where it should be the key of the bucket, and then this will be the path of the file that you stored in the bucket. So I guess a question a lot of you are asking is a bit of a quite difficult or complicated to communicate with this S4 server from all these kind of programming languages. So how do we achieve this? It's achieved with a sidecar container. So this slide that you're seeing here represents an example application using S4. So if we had an application, I've got a Node example here. I've titled it My App. We have a Node application, and we want to store the data. We want to store, say, images on S4 instead of S3. How do we do that? So we run our two containers, our Node.js container here, and our S4 client, which acts as the sidecar container. The code inside the Node app, you should surely will be able to recognize a lot of this code here. We import the official Amazon AWS SDK, and we even instantiate the S3 class of that. But notice here, the endpoint is pointing to our local S4 client, which is this container here, you can see. And we also provide it with the access key and secret access key as well. And we can use all of the existing AWS methods that the SDK provides us completely. There's no other modification has to be used. But when I put this object into the bucket, it will go over Tor into S4 and then be published to IPFS. So then on to reading data. How do we read the data from S4? Again, I had a few specifications on how I wanted to make this work. Namely, the fact that I didn't want to use JavaScript. The beauty of S4 is that the data gets requested over HTTP gateways, meaning that if you don't want to use JavaScript and you just want to have a plain image tag, you can have a plain image tag, and that image will be loaded over S4 using a public gateway. This also allows for human readable file paths. This hash only references the bucket. Therefore, all the content is human readable, as you see here. So I've said a lot there. Let's try and do a live demo where we're going to actually create an S4 server. If anyone's interested in following along with this, you can go to this URL here. idea inc/s4, and you can follow along. It only requires 4 commands to actually start up the server. So let's give it a go. So if we head over to the GitHub, here is the S4 GitHub repository. I will just get the URL and my temporary directory here, and I'm going to run the command git clone S4. And we'll cd into the S4 repository. And once you're in the repository, first thing we have to do is we have to make a onion address for our server. We have to have a private key. So we can do that using this command here. Again, this is all provided in the README of the repo. So it's pretty much just copy and pasteable. If we run that command, what happens? Great. It's generated us this onion address here. Now, this onion address is referencing, or this is the onion address for our local S4 server that I'm going to run now in Docker. Then to get the project started, simple as running the command docker compose up. Great, and it looks like it's all starting there. Brilliant. So what have we done here? We've now fully set up our S4 server in just those 4 commands. It's as simple as that. So I'll give it a moment to boot up, and it looks like Tor has bootstrapped properly. So if I open up Tor browser, it might take a second because the domain needs to be published and stuff like that. But after about 5 minutes, that URL that you just created will become accessible over Tor browser. So we'll give that a moment. And let that load. This might take a second. So what we'll do is we'll continue on with the rest of the presentation. So now we have this S4 server set up, or right now it's running on my laptop. We can go ahead and assume that this is, say, some server which is somewhere on the planet. Obviously, the actual IP address is unknown because it's using Tor. So how would our application actually write data to that? So I'll give a quick example. In the root of the S4 repository, there's a directory called example. And this example directory is the example I just gave in the presentation, demonstrating S4 working with the official AWS SDK. First, we have to quickly update the env and give it our S4 address. We'll exit that. Then we run the command docker compose up -d, and now we'll up that. Good. So that now is booting up which would be like an application which might write S to S4 in production. So let's actually test and see if we can. Now we're going to run this block of code here, which hopefully will be able to create us a bucket on our server and upload a file into that server. So I'll run the command. Here, again, all of these commands are in the README of the repository. And it looks like we've successfully created our bucket, and we've successfully uploaded a file into that bucket. So this here represents how we can upload content from our application into S4. And now this PDF file, example.pdf, which is uploaded into into S4, hopefully now will be accessible over IPFS. So let's see if that's happened. Let's quit out of that. Here we go. So Myhre is like an open source version of AWS S3. All the API methods are compatible with S3. So I'm just going to quickly try and log into it now. And hopefully we'll be able to find our file in there. And then I'll also be able to show you how you can actually read that file, over IPFS. So wait till we've logged in. There we go. So what I'm doing now is I'm doing the equivalent of logging into the S4 server. And as you can see here, this is the example file that I've just uploaded through using the example code. But the obvious question is, how would I then access this file over IPFS? Now there's a bucket which isn't published to IPFS called system. And inside the system directory, all of the hashes to those keys are accessible here in this file. So this hash is the key that this bucket was published under. What that means is if I go to ipfs.io/ipns, now this won't load straight away, obviously, because it's going to take a moment to actually find that bucket. But what happened is after that bucket started propagated over the IPFS network, you'll be able to navigate to that URL and also be able to navigate to /example.pdf, and that will then load that file then over the IPFS network. What this allows us to store data on IPFS without requiring developers to actually change any of their code. I think there's a lot of great projects in the IPFS community right now, but I don't think it's massively realistic to expect large corporate companies and development teams to change their code to kind of fit with IPFS. It makes far more sense that we make IPFS and augment any of those changes that are necessary. And that's what I've managed to do here using this kind of sidecar container system. This allows developers to keep their existing code, but then write the data to IPFS under the hood with no changes whatsoever required to their code. So that's pretty much everything I had today. I'd like to wonder if there's any questions I could kind of put out there for anybody.
Wow. I feel like I've had my mind blown so many times in just this 1 hour. Does anyone have any questions for Anthony?
No.
All right. Well, we are almost at the top of the hour. So thank you so much, Anthony. I've just got a few things to say before we say goodbye to our November meetup. So for next month, we are going to wrap up 2020 in a box and say goodbye. We're not going to give it to anybody, but it's a gift that no one should ever have to open. So for December, expect that there will be loads of updates from the IPFS project team recounting what's been accomplished. And I guess we'll call it this year. It feels like maybe it's been longer, but anyway, we'll also be having our top collaborators from the community join us to give highlights from their year as well. So to get notified about this, our next meetup, join one of the meetup groups nearest you on Meetup. You can subscribe to the IPFS weekly newsletter, which I write, or follow us on Twitter and stay tuned for more news on our last meetup of 2020. We are also going to be producing videos from this meetup, so make sure that you follow us on Twitter or subscribe to the YouTube, and you can see the presentations from today and share them widely. And if you have any questions about the presentations or IPFS, feel free to drop a question in the box, or if you want to speak at one of the events in 2021, make sure to send us an email at ipfs-community@protocol.ai, and we will see you next time. Thank you so much, and have a good rest of your Tuesday. Bye.